Tilt-a-worlds may expand habitable space. Exoplanets with fluctuating tilts in their orbits may support life in places where fixed-spin planets like Earth couldn't. That's because these tilt-a-worlds have a different relationship to the planets around them. Earth and its planetary neighbors circle the Sun on about the same plane. But tilt-a-worlds and their neighboring planets orbit at angles, tugging at each other's orbital planes in a way that occasionally spins a tilt-a-world's poles toward its host star. The spinning may resemble the wobbling of a child's top when rotating at a slow speed. Tilt-a-worlds are more likely than fixed-spin planets to have liquid surface water. That's because the heat from a host star is more evenly distributed on the surface of a tilt-a-world, especially when its poles are turned toward its sun. The planet's ice caps will melt quickly, creating surface water and making the planet more likely to support life. This characteristic of tilt-a-worlds may expand the edge of a star's habitable zone by 10 to 20% past the point where fixed-spin planets would freeze over. Researchers question whether we're ready for contact with alien life. NASA is taking an aggressive approach to finding alien life in our universe. The Search for Extraterrestrial Intelligence (SETI) project has also become more ambitious in its efforts to contact alien civilizations. SETI wants to move beyond the mere searching and tracking of extraterrestrial signals, and start actively sending messages through space to identify our position to others. But contacting intelligent alien life may be a danger we're not prepared to handle. Stephen Hawking has warned that a superior civilization would most likely use their power to dominate us. There is also concern that NASA and SETI are overstepping ethical boundaries. As neuropsychologist Gabriel G. DeLautor asks, can such a decision be taken on behalf of the whole planet? What would happen if it was successful and someone received our signal? Are we prepared for this type of contact? Based on a survey of college students, DeLautor believes that the general public currently lacks the knowledge and preparation needed to deal with intelligent alien contact. Most people's viewpoints are also influenced by their religious beliefs. Eccentric exoplanets may host extreme life forms. For the most part, astronomers search for life on exoplanets that reside within their star's habitable zone. But some eccentric exoplanets remain in the habitable zone only part of the time. When outside the zone, they may experience molten hot or frigid temperatures. Even so, these planets may still support life. Scientists point to certain microscopic life forms on Earth that can live in extreme conditions, both on Earth and in space, such as bacteria, lichen, and spores. This suggests that a star's habitable zone may extend farther than initially believed. But we have to change our thinking to include planets hostile to life on Earth, but favorable to life forms that thrive in, or at least tolerate, harsh conditions. Advanced alien life may be detected by pollution. Until now, scientists have searched for alien life by looking for exoplanets rich in gases like oxygen, carbon dioxide, and methane. But since the Webb telescope should be able to detect ozone-destroying chlorofluorocarbons, some researchers now suggest we consider looking for industrial pollution to find advanced alien life. While we hope to detect an alien civilization that's still alive, it's very feasible that we might find an extinct culture that destroyed itself. Scientists believe the best way to tell if a civilization still exists is by searching for both long-lived pollutants that stay in the atmosphere for tens of thousands of years, and short-lived pollutants that last only a decade or so. If the Webb telescope detects only long-lived pollutants, then the alien civilization may be extinct. But this method does have its limitations. The Webb telescope can so far only spot pollutants on an exoplanet orbiting a white dwarf, the remnant of a dead star, roughly the size of our Sun. Dead stars typically equal dead civilizations, so the search for actively polluted life might have to wait until our technology grows even more advanced. Oceans may make exoplanets more habitable. To determine which planets may support intelligent life, scientists usually focus their computer models on the atmospheres of planets within a star's habitable zone. But new research suggests that our models should also factor in the impact of large, liquid oceans. Let's use our own solar system as an example. Earth has a stable environment that supports life, but Mars, on the outer edge of our habitable zone, is frozen. It has temperatures that may fluctuate by over 100 degrees Celsius, 212 degrees Fahrenheit. Then there's Venus, on the inside edge of our habitable zone and scorching hot. Neither planet is a good candidate to support intelligent life, though they may host microorganisms that can survive in extreme environments. Unlike Earth, neither Mars nor Venus currently has a liquid ocean. According to David Stevens of the University of East Anglia, oceans have an immense capacity to control climate. They are beneficial because they cause the surface temperature to respond very slowly to seasonal changes in solar heating, and they help ensure that temperature swings across a planet are kept to tolerable levels. That's why Stevens believes we should factor the presence of oceans into our models when searching for alien life.